Alright, so this will serve as the first problem to be solved. Okay, let's say we have a ball. Okay, we have a ball mass at 2.5 kg, and this ball being kicked by players, which resulting this ball to accelerate at 40 meter per second. So the question here is how much force being applied by the kickers. Okay, one is sepak bola, it caused the ball to accelerate 40 meter per second, and this ball is 2.5 kg. How much force being applied? Okay, berapakah? Ini straightforward equation ni. Berapa jawapan kita?
.5 kilo saya tu.
Yup, 2.5 kg.
100.
100 apa?
100 meter per second.
Oi, bukan. Kita cari F.
Bukan. Oh, okay. Sorry.
100 apa? 100 betul?
Joules.
Bukan.
Ya.
Force. Joules untuk apa?
Newton, sorry.
Yeah, Newton. Joules untuk apa Joules? 10 joules, 20 joules. Nah, untuk apa ni?
Distance.
Bukan, joules tenaga. Dia bukan distance, distance meter. Kita ada joules, kita ada watts. Ni kat bahagian power, energy, work. So joules being used for dua ni, power and energy. Okay, ni tenaga, ni joules ni untuk tenaga. Alright, we go to the second problem. Okay, we have a basketball shoe. Kasut basket bola. Okay, surface of basketball court. Alright, if the coefficient of friction between these two surfaces is 0.56 and the normal reaction force for the shoe is 350 Newton. Okay. How much horizontal force required to cause the shoe to slide? Question is, if we want to push this player, how much force needed in order to make it slide? Berapakah? Ni senang, simple je ni. Okay, kita ada coefficient of friction and kita ada normal reaction force equals to 350. Maksudnya at any given time at any given point of time, the force acted upon the shoe to the floor is 350. So how much force horizontally means we need to actually surpass or overcome the threshold of friction here. So kita kena tahu dulu berapa force of friction yang ada dekat sini. So it will be normal reaction force time with coefficient dulu. 350 kali dengan 0.56, barulah kita dapat
196
100
Newton. 196
Newton. Okay, this is net force for this system. So if we try to make the shoe slide, berapa banyak force kita perlukan? Kita dah tahu force at this system is 196. So if we want to make this shoe slide, maksudnya kita nak overcome this threshold, how much force is needed? Jawapan ada kat situ, tambah satu benda je. Greater than 196. Apa maksud dia? Maksud dia kaki ni kan, kasut ni. Okay, at any given point of time, this kasut ada 196 Newton. Or, kalau tulis ke bawah ni orang kurang faham, dia jadi macam ni. Dia ada 196 Newton. Jadi kalau kita nak tolak dia, in order to make this shoe slide, means we need to have force larger than 196. 197 Newton. Dah boleh bergerak. Tu maksud normal reaction force. Okay? Jadi kalau kata kotak, normal reaction force dia 100 Newton. Means that at any given point of time, it give the ground 100 Newton. Berapa banyak tenaga kita perlu untuk tolak? Kita kena tengok coefficient of friction dia. Exceed this one. And then the box is going to move. This is Newton's second law. Okay. We go to the next one. Tak banyak soalan kita ini, sikit je. Okay. Next one, kita ada football players. American football players. Pushing sled. Okay, ada tolak sled. Okay, a football player push a tackling sled. So this sled is 670 Newton in weight. Okay. So the coefficient of static friction for between the sled and the grass is 0.73, and coefficient of dynamic friction between sled and grass is 0.68. Soalan pertama, how much force needed in order to make the sled move? Berapa banyak force kita perlukan untuk menggerakkan sled itu? Okay, so in order to do that, we need to know, ni 670 ni normal reaction force dia. Jadi kita perlu tahu berapa net force dia. Okay, we need to know how much net force in the system. And to know net force is equals to force normal reaction time with the coefficient of friction. Jadi untuk mula menggerakkan, we are going to use the static coefficient of friction first. Jadi kamu dapat 670 0.73. Berapa?
489.1 Newton.
Okay, 489.1 Newton. If we give this amount of force, are the sled going to move?
Greater.
Yes, greater. Jadi kita dah tahu jawapan. Jadi jawapan dia ialah kita kena bagi force greater than 489.1 Newton to make the sled moving. Okay, soalan nombor 2, how much force needed to keep it moving? Keep it moving. Sekarang dia dah mula bergerak. Sekarang berapa banyak force kita perlukan untuk teruskan pergerakan itu. And this is the time where we consult coefficient of friction dynamic. Sama jugalah, kita cari net force dia dulu, equals to force normal reaction time with coefficient dynamic. 670 0.68. Okay, berapa dapat?
455.6.
Okay, jawapan dia, how much force needed in order to keep it moving?
Greater juga.
Greater than 455.6 Newton. Ni isu friction. Okay, friction is another form of force. Okay, now kita gunakan equation yang sama. Okay, tapi kali ni ada sedikit pertambahan. So we know that the coefficient static is 0.73. Okay, 0.73, and coefficient dynamic equals to 0.68. Okay, now ada satu bakul darah pula duduk kat ni. coach dia pula duduk. This coach is 100 kg in term of weight. Please find the new net force for static and new net force for dynamic. And then answer how much force needed to make it move and how much force needed to keep it move. Okay, silakan. Tengok ni jangan lupa This is in kg, this is weight. Kita kena guna mass. So, translate this one into Newton dulu. Times by 9.81.
981 Newton.
981 lah kan?
Ha.
Ha. Sled ni tadi 670.
670.
So the new, kita panggil dia sebagai the new apa ni? The new system is 670 tambah 981 115 1651 Newton. Okay, now use this as part of that one. Maksudnya ni adalah normal reaction force yang baru. Tadi kita 670 je, but now the normal reaction force is 1651 Newton. Lepas tu tukar, masukkan je lah. F net static equals to 1651 0.73 and number 2 F net dynamic 1651 0.68. Okay, berapa kita dapat?
Yang atas 125.2.
Bawah.
Yang bawah 1122.7.
Okay, so the answer will be greater than 125.2 Newton for the first one, and number 2 greater than 1122.7 Newton. Itulah jawapan dia. Okay. Okay kah? Are you
Okay, sir.
okay? Are you okay? Okay. We go to the next one. This one is a concept of momentum. Still remember conservation of momentum, where m1 v1 equals to m2 v2. So if a collision occurs, it will be m1 v1 plus m2 v2 equals to the new complex equation. This is equation of conservation of momentum. Okay, so now we have a case of collision. We have two people. These people, the first person is 100 kg, okay, 100 kg in mass, travel at a velocity of 4 meter per second, while another person has a mass of 90 kg, okay, this is A, this is B, travel at a speed of 4.5 meter per second. So the question is, what happened after they collide? Apa jadi lepas dia berlanggar? Dia bergerak ke mana? That will be the question. So please use the equation that been given in order to solve the problem. Okay, ini akan jadi 1, ini akan jadi 2 lah. So saya keluarkan maklumat dia dulu. M1 100, V1 4, M2 90, V2 4.5. Okay, sila selesaikan. Betul tak equation ni? Is there anything wrong here?
Bukan. Okey, tak ada apa saya.
Apa dia?
Tak ada apa, tak ada apa.
Ada salah kat sini. Saya suruh kamu cari. What is the mistake here?
Saya rasa yang 4 tu negatif 4.
But it is not 4, it is 4.5. Bukan yang ni. Yang ni kan bergerak daripada kiri ke kanan. Yang ni kan bergerak daripada kanan ke kiri. Anything that move to the left is negative.
Negatif.
Kita ada negatif kat sini. Kalau kamu miss out this negative, jawapan jadi lain. Okay, berapa? Kita dapat berapa? Negatif 5 bahagi 190. How much you get it?
Negatif 0.03.
0.03. Okay, betul. Dah bunda Negatif 0.026 atau 0.03 meter per second. Okay, soalan dia tadi, after the collision, what happened? Can you describe what happened after the collision? Okay, soalan dia tak habis. So, kamu kena habiskan. So, means that the question asks, what happened after the collision? So, after the collision, we know that the figures is negative. Means, both of players travel in the direction of player B. Pasal dia bergerak ke kiri. Based on negativity di situ. Barulah habis soalan ini. Okay, so let's move on to the next one. Soalan ni senang sangat, kita skip je. Okay, kita masuk kepada soalan yang kita belajar last week. Okay, which is regarding work, power, energy. Okay, now let's say we have a set of stairs. Kita ada tangga. 20 flight. Okay, 20 anak tangga. Ya ke? 20 anak tangga. And each anak tangga, the height is 20 cm. Dia punya height. Okay, 20 anak tangga, 20 cm each. Okay, if a person this person, the weight of this person is 700 Newton. Weight dia. And it takes this person the time taken to finish it up is 1.25 second. Dia berlari ni. Okay, calculate mechanical work. 1. Number 2, calculate power. And number 3, change in potential energy. 3 benda. Okay, work, power, change in potential energy. For formula kita ada work, we have force over distance. Power, kita ada work over time. And then PE
Plus KE.
height kali weight. Okay, height kali weight. So kalau dia kata situ change of PE means that PE 2 minus PE 1. PE2 will be at the top of the stair, PE1 will be at the bottom of the stair. Okay, silakan. Saya keluarkan maklumat dia. We have height equals to 20 cm per stair. And we have 20 stair. Weight is 700 Newton. And the time is 1.25 second. Kena selesaikan ni dulu. 20 kali 20 sama dengan 400 cm sama dengan 4 meter. Ni bukan bahagi. Let's not divide. Salah di situ. It is FD. Force dengan distance. Okay.
So, force dia tak ada kan?
Ada?
Ah?
Ada.
Wait, sekejap.
Maklumat dia ada dekat situ, but it does not show as force. It is showing as
Okay, betul 700.
700. Can we have the first one? Berapa dia punya work done? Force, distance. Simple ni. 700. Weight, jangan lupa weight tu kan, weight tu ialah force. 4. Okay.
2,800
2,800.
Apa dia?
Newton
meter. Ataupun
joule kot.
joule. Janganlah kod betul tu. Okay, power dia work over time, which is 2,800 Newton meter over 1.25 second.
2,240
2,240 apa?
Joule per second.
Boleh? Joule per second, boleh. Pasal tadi kan kita ada joule, now kita ada second, so joule per second boleh. Watts pun boleh. Newton meter second pun boleh. Okay, yang last one. Last one ni tricky, tapi janganlah sakit kepala sangat. Change of potential energy. Okay, to answer this one, we go back to the equation of energy constant. Okay, where we have PE plus KE equals to C. Okay, based on here, the information that I need you to have in your mind is PE maximum dekat mana? PE max dekat mana? Dekat atas sekali. So PE 2. PE dekat 1, PE at the bottom ada PE tak? Do you have any potential energy when you start at the bottom?
No.
No, because
Zero.
height dia kosong. Okay. Kalau kata kita nak buat ni satu-satu, I'm going to show it here. Okay. PE, dia nak change. Okay, change of PE equals to PE final minus PE initial. Okay, sama dengan height kali weight final. Tolak height kali weight initial. Height dia berapa? Height final dia berapa? Tadi, atas sekali. 20 kali 20 sama dengan 400. Sama dengan 4 meter.
4 meter.
Okay, so 4 kali dengan weight dia berapa? 700.
700.
Tolak. Height mula dia berapa? Ni height habis, final. Height mula dia berapa? Dekat bawah.
Zero.
Kosong lah.
Zero.
Weight dia 700. So automatically kita dah boleh slash. So the change of potential energy is 2800
800.
joules ataupun Newton meter. Yang ni memang soalan macam ni kena dengar betul-betul soalan dia. Dia sebut change of dah mula pada bawah habis kat atas, the highest is the biggest. Bawah confirm kosong because at the beginning there are no height. Dia tak cerita tinggi orang, dia cerita tinggi tangga. So kena dengar betul-betul. Okay, so the answer will be 2800. Okay, now let's try another one. Okay, ni dia. Sekejap yang ni dia ada. Okay. Alright, this is quite a tricky question. We have performed a maximal vertical jump. So we go with the vertical jump cases. A person jumping. Okay. So a 50 kg. So the weight of this person is 50 kg. Ni dia punya weight pula. Dia punya mass. Okay, this is the mass of the person. 50 kg. Okay. It make a vertical jump with an initial velocity. So velocity dia dekat bawah ni, masa dia mula-mula lompat, is 2 meter per second. Okay, so maklumat kita ada mass 50 kg. Initial velo ataupun V1 equals to 2 meter per second. So question dia, A, max height dia berapa? B, berapa dia punya max potential energy? C, berapa dia punya minimum kinetic energy? And D, how far performer COG elevated? Okay, 4 betul. Apa lagi? Jawab lah. Silakan. Apa kita kena cari dulu dalam benda ni? What are the things that we need to find based on this equation? Semua ni PE, KE apa semua. So the first one, when you see this kind of problem, find C. Constant ni cari dulu. Because this constant talks about the energy you have in the system. Barulah kamu boleh tahu berapa tinggi, berapa laju, berapa berat ada dah. Okay. So we need to find C first and then only kita boleh selesaikan yang lain-lain ini. We need to know how much energy we have within the system dulu. Okay. So how we want to find out C? Okay. Weight plus time height plus half mv square equals to C. Kita nak cari dia dekat mana sekarang mv square ni? Kita nak cari dia dekat point mana? Yang mana sebenarnya kita boleh selesaikan? Kita ada V initial at the instant of jumping. Kita ada M. PE kita tak ada. So kita selesaikanlah dekat bahagian Mula-mula ni dia lompat. Janganlah cek dekat atas. Kita cek dekat mula-mula dia lompat. Because dekat mula-mula dia lompat, PE equals to 0. There is no height. Plus half M. Mass dia 50. V dia 2 square C. Dampaklah C dia berapa? 2, 4, 50 kali 4. Berapa kan 50 kali 4? 5, 4,
100.
200 kali setengah. 100. So we know that the system contain 100 joules. 100 joules here, 100 joules there. Kalau daripada jawapan ni kan, kita dah tahu tak max PE dia berapa? How much max PE ni?
100.
100. Selesai. How much, how minimum KE? Minimum KE dekat bawah sekali lah.
0.
0. Kadang-kadang benda ni nampak susah tapi senang. Okay, berapa maximum height dia boleh pergi? Can we do that? Max height. This one use the same equation, but now we know at the apex the velocity is berapa?
0 kan?
0 lah. Jadi, untuk max height, kita akan pakai benda yang sama. PE plus KE equals to C. Where here, since V dia kosong, KE dia kosong. So, kamu just tinggal PE, weight kali dengan height. Berapa weight dia? Can we have the weight?
50 kg.
Itu dia punya mass. Itu dia punya mass. Kg is mass. Weight ialah 50 kali dengan 9.81. Tu bahagian weight. Lepas tu kali dengan height dia kita tak tahu, sama dengan 100 joules. Boleh selesaikan tak? HT equals to 100 bahagi 50 kali 9.81.
So yang 9.81 tu yang mana?
9.81 gravity?
Oh, okay.
Kan ni mass 50 kg. Change mass to weight kali dengan gravity. Tak tinggi pun dia lompat. Rendah je. Ni dia punya, apa tadi? Apa soalan ni? Maximum height. So, soalan tu menjawab dua benda sebenarnya, maximum height. Okay. Maximum PE kita dah tahu dekat atas. Minimum KE ni dekat mana? At the base or at the apex?
Base.
Ulang balik.
Sekejap, KE
Kat atas.
minimum. Atas.
Minimum KE dekat atas. Maximum PE dekat atas. Minimum PE dekat bawah. Maximum KE dekat bawah. Ni ingat ni kita buat kan macam ni, pergerakan macam ni. So sini KE minimum. Sini KE maximum. Same goes here. PE pula sini kosong. PE sini maximum. Pasal apa? Pasal height. Yang ini pasal apa kosong? Pasal V kosong. Okay. Soalan nombor 4. How far the performer COG elevated? Berapa COG dia berubah? COG dia berubah sama dengan maximum height 0.2. Pasal that is the change of height dia. Dan dua soalan ni terjawab sekaligus. Okay. Quite a simple one. Let's go to the last one. Right. Okay. Using the principle of conservation of mechanical energy. Nama pelik tu. Principal Conservation Mechanical Energy. The name is pelik, but the thing is this one. Plus KE equals to C. Okay, using this one, calculate the maximum height. Okay, dia suruh calculate maximum height can be achieved by a 7 Newton ball being tossed vertically with an initial speed of 10 meter per second. So dia nak kita cari height dia. Can we do that? Apa yang kita boleh cari dulu mula-mula? Sama macam case tadi. First one, always find out C. Berapa C dia? Barulah boleh cari yang lain. Okay, so to find C, we are going to consult with the same equation. Height time weight. Okay, that is PE plus half.
So kalau weight time height boleh ke?
Boleh, sama je.
Okay.
Terbalik ni, terbalik boleh, tak ada masalah. Plus KE sama dengan C. Cuma dekat sini, this play a major role. Saya nampak kamu ada isu dengan ni. Bila dia bagi 7 Newton, meaning this one is weight. Kalau mass, it will be in kg. Tu ingat tu. Habis kalau weight ni nak tukar jadi kg dah, gaya mana? Weight to mass bahagilah dengan 9.81. Mass to weight darab dengan 9.81. Now kita ada 7 Newton. 7 Newton berapa mass dia? 7 bahagi dulu dengan 9.81. 7 bahagi 9.81. 0.71. That is the mass. So mass dia ialah 0.71 kg. Bolehlah selesaikan ni. Jadi kita ada information dekat base. Automatically PE kosong. Plus half 0.71 10 square. Berapa C dia?
$35.5.
35.5. And don't forget to put the unit. Dah dapat C, bolehlah selesai. Berapa tinggi maksimum dia boleh pergi? Same equation. Equals to PE plus KE. Now, we want to know the maximum height. So, we want to solve this one. Automatically, we know that at the apex, KE 0. Jadi, C ni tadi 35.5 sama dengan berapa dia punya height. We don't know the height. Berapa dia punya weight? 7. So, automatically, height dia ialah 35.5 bahagi 7.
5.1.
5.1 apa? Meter. Tinggi meter. Don't forget to put the unit. Pasal 5.1 ni ada banyak macam maksud. 4.1 apa ni? So we put a unit and then you solve the equation. So these are the maximum height able to be achieved by the ball that being tossed with an initial speed of 10 meter per second. So that will be the end of our tutorial class for today. Ada soalan? Any question? Enggak ada. Ada. Ada soalan apa-apa tak?
Takut.
Takut. Okay. Soalan kita pun hari ni clear cut ni soalan. Alright. So if you don't have any more question, this will serve as the end of our class.